DeepSeek AI is an emerging AGI research lab that recently beat top AI companies such as OpenAI and Anthropic on several industry standard benchmarks. In this video, we're going to break down what it all means and why it matters, and we're also going to show how you can run some of DeepSeek's latest R-series models on your laptop. Here's an overview of the following sections. This is going to be a three-parter. In part one, we're going to do an intro to DeepSeek AI. In part two, we're going to show how you can run some of the smaller R1 models that were recently released. And then in part three, we're going to do a cost analysis of some of the larger models offered by DeepSeek AI so we can get a feel for what the impact of all of this is going to be. As always, excuse any mispronunciations and leave a comment if anything I say is inaccurate or false. According to LinkedIn and X.com, DeepSeek AI is an AGI research lab based in Hangzhou, China that was founded in 2023. While DeepSeek AI has been releasing open source models consistently since 2023, the latest batch of text-based models released on January 20th, 2025 went viral after the accompanying research paper claimed that some of them could outperform a handful of systems designed by top AI companies, like OpenAI and Anthropic, for example, across several industry standard benchmarks. The complete list of benchmarks that were used for evaluating the latest batch of models released by DeepSeek AI can be found on Table 4 of Section 3.1 in the R1 research paper. And to give you a taste of what they mean, MMLU consists of 14,000 multiple choice questions spanning over 50 different subjects. GPQA consists of answering questions that are considered to require graduate level knowledge. Simple QA consists of answering questions about a variety of facts. Code Forces consists of coding challenges that have to be solved within an allotted amount of time. SWE Verified consists of solving GitHub issues related to several code bases, most of which are written in Python. AIME consists of advanced high school level math problems. Math 500 consists of 500 quote unquote difficult math problems. And CEVAL is the Chinese equivalent of MMLU, if I'm not mistaken. So pretty much what this is saying, assuming it's accurate that is that in the domains of A, answering general English questions, B, coding, C, math, and D, answering general Chinese questions, DeepSeek R1 671B, aka the largest model in the latest batch of models released by DeepSeek AI in January of 2025, is outperforming leading models built by top AI companies in certain industry standard benchmarks. As a quick side note, I'm wondering why the scores for so many benchmarks were omitted for the O1 column, but for the Drop, Live Code Bench, AIME, and Math 500 benchmarks, DeepSeek R1 671B seems to be the highest scoring model. Caveat 1. Keep in mind that if the data related to these benchmarks was a part of the training data, then it's possible that the models that are scoring the highest are simply memorizing the answers. This is not a true test of intelligence, but more so a test of memorization, something that you'll hear ML engineers call overfitting. Caveat 2. Keep in mind that this does not give a definitive assessment of which model is the absolute best, as this table or rubric represents only one way of comparing them. Caveat 3. Keep in mind that these R1 models are what are known as System 2 or reasoning models that can, by design, take up to several minutes to provide answers to prompts. So they're a bit different from the System 1 models that power applications like ChatGPT and Claude from a user experience standpoint. Regardless of these caveats, however, this is impressive, as many people, myself included, had never heard of DeepSeek AI prior to the release of the R1 paper and the media frenzy that soon followed. Additionally, as if that wasn't enough, some of the smaller R1 models, referred to as the Distill models released in the same batch, are also outperforming several leading AI systems on some of these benchmarks as well. So that's the intro into what DeepSeek AI is, what they've been up to, and why these R1 models created so much buzz. We are now going to show how anyone with a laptop can run one of the smaller R1 series models from DeepSeek AI using a combination of three tools: Ollama, OpenWebUI, and Docker. The only requirements you'll need are a sufficient amount of hard drive space, at least 100 gigabytes is more than enough, and a sufficient amount of RAM, at least 16 gigabytes is recommended. While running AI models locally is not going to be a fit for everyone or every use case, the nice thing about it is that the data regarding your interactions with whatever AI model you're running are going to be kept private and the data will not be leaked off your machine. The exact model we're going to be running is called DeepSeek R1 Distill Llama 8B For simplicity, I'm just going to refer to this model as R18B moving forward. In the latest batch of models released by DeepSeek AI in January 2025, 6 of them are referred to as quote-unquote distill models. What I understand this distill term to mean is that the team at DeepSeek AI started with a handful of open source AI models, for example, Qwen 2.5 Math 7B from Alibaba or Llama 3.18B from Meta, and then used DeepSeek R1671B, aka the largest of the R1 models, to generate 800,000 synthetic training examples that were subsequently used for fine-tuning. The term synthetic training examples means that instead of collecting data from the real world, AI researchers simply prompted DeepSeek R1671B, aka the big daddy of the R1 series models, 800,000 times and took whatever the outputs were for each prompt as the correct answers. A common analogy you'll hear for describing how this fine-tuning or distillation process works is it's sort of like a teacher showing a student a bunch of examples of how to respond to various inputs and having the student emulate the teacher's responses. Let's now move away from this technical stuff and show how to actually use this technology. While I'll show how to do this on a Mac, the general flow of what you'll see will apply for Windows and Linux as well. Here's a diagram showing what we're about to do. If you've never heard of Ollama, Ollama is a free open source tool that makes it easy to download and run AI models. Ollama offers support for Mac, Windows, and Linux and can be installed in less than a minute. Let me show you. Come over to ollama.com and you should see this download button. And after you click that download button, you can select the appropriate version for your OS. Mine is Mac OS, so I'll click this download for Mac OS button and that'll kick off a download. After the download is complete, you should see a zip file in your downloads folder. Unzip the zip file and drag the resulting application into your applications folder. You can then launch Ollama just like you would launch any other application. First time you launch it, you should see some consent dialogues. I'm providing my account password. And that's it. When Ollama is running, you should see this little llama icon in the top menu of your desktop. Ollama is primarily a command line tool, so while you can launch it and shut it down with your graphics interface, you will need a shell to interact with it. So let's pop open a shell. And for example, let's type Ollama list. This will show you the list of models that you've downloaded. We haven't downloaded any yet, so that's why this list is empty. Now let's type Ollama PS. This shows you the list of models that are running. You can see that we're not running any models yet. And if you type Ollama help, you'll see the complete list of commands that Ollama offers. If you've never heard of OpenWebUI, OpenWebUI is a free open source web application that has a very similar interface to ChatGPT. In order to run OpenWebUI, though, we have to download another free open source tool called Docker. Downloading and installing Docker should only take a few minutes. Let me show you. Come over to docker.com and download the appropriate version for your machine. For me, this is Apple Silicon. That'll kick off a download. When the download is complete, you should see a DMG file in your downloads folder. You can double click to open and you can drag the docker.app icon into your applications folder. After that's done, you can open Docker just like you would open any other application. Provide your consent. This is the first time we're launching it, right? And when Docker is running, you should see this little whale icon in the top menu of your desktop. Now that we have Ollama installed, we can run R18B with a single command. And now that we have Docker installed, we can launch OpenWebUI with a single command too. Here is how we run R18B. So let's come back to our shell and enter the following command. Ollama run deepseek-r1:8b. The model's name in Ollama is slightly different than the model's name as shown in the original research paper from DeepSeek AI, but close enough, right? While R18B is downloading, let's come over to ollama.com for a quick browse. So we're familiar with the landing page of ollama.com. We're familiar with the download page. Let's come over to the models page and see what's going on here. So This is a leaderboard of the most popular models that are currently being used in the Ollama ecosystem. And we can see at the top of this leaderboard is DeepSeek R1. We can click this item to be taken over to a detail page that gives us a little bit more information about all of the related models. Here we can see there is 1, 2, 3, 4, 5, 6, 7 models associated with DeepSeek R1. And this lines up with what the DeepSeek R1 research paper says. We're going to be playing around with the 8B, right? And we can see that it is based on Llama. We can see that if we were to download this model onto our computer, it'll take up 4.9 gigs of hard drive space. For reference, let's also take a look at the Big Daddy, the 671B. So here we can see DeepSeek R1 671B is based on DeepSeek 2. And if we were to download this model onto our machine, it would take up 404 gigs of hard drive space. In regards to RAM, there is this handy note on the Ollama GitHub repo that reads, you should have at least 8 gigs of RAM available to run 7B models, 16 gigs to run 13B models, and 32 gigs to run 33B models. Now that I've been playing around with Ollama for several months now, the pattern that I'm picking up on is that for every 1 billion parameters a model has, you'll need about 1 gig of RAM. So to drive this home, on the machine that I'm demoing on, I have 500 gigs of hard drive space and I have 16 gigs of RAM. So in regards to the Big Daddy, the R1671B model, I do have enough hard drive space to store it, right? Because 404 gigs is less than 500. But I don't have enough RAM to run it. But in regards to the R18B, the R18B only requires about 4.9 gigs of hard drive space and only about 8 gigs of RAM. My machine has 60 gigs of RAM, which is more than 8 gigs, so we're good. Hopefully you have a feel for how this all works. FYI, hard drive memory is a type of memory technology used for long-term storage, whereas RAM is used for running applications. RAM, aka random access memory, is a type of memory technology that's capable of being read and updated much faster compared to hard drive memory, but is not designed for long-term storage. Okay, now it looks like DeepSeek R18B is running, so next let's run OpenWebUI. If we come over to openwebui.com and click on this Get OpenWebUI button, it'll take us over to the GitHub repo for OpenWebUI. And if we scroll down to the README, eventually we'll see some commands that we can copy paste. And this is the one that we want. If Ollama is on your computer, use this command. So I'm going to copy this and let's come back to our shell, open up a new tab, paste, run. And when this command is finished, we should be able to visit port 3000 in our browser, and we should see the OpenWebUI web application. Okay, now that this Docker command has finished running, we should be able to come over to our browser and visit localhost port 3000. Here I'm reloading. And there we go. It did take a couple of seconds to boot up after the Docker command finished, as you saw. But here we are, localhost port 3000, and we have our OpenWebUI application running on our machine. Next, let's shut off our internet connection just to prove that there are ways of using DeepSeek AI technology privately. And let's get started. This is a bit strange, but this is how OpenWebUI works. So by default, it comes with a login system. So you'll need to provide some credentials. These are going to be stored in a local SQLite database. Put whatever you want. And here we are, we're logged in. And because we already have DeepSeek R18B downloaded and running, OpenWebUI should pick it up automatically. In case you're not seeing it, you can enter the Ollama model ID for DeepSeek R18B here and click this button that says pull DeepSeek R18B from Ollama.com, right? That'll set everything up for you. But it looks like we're good to go. And hopefully this user interface seems very familiar to you in the sense that it's very much like ChatGPT. You have your chats over here and you can send messages to a model here. So if I say hello, we are now interacting with DeepSeek R1AB, right? Here's the next prompt that we'll test. Tell me an inspirational quote from Nelson Mandela. If we pop open this, we can see the internal dialogue the model is having with itself, and then we get the final response. Here is the next prompt that we'll test. Write some marketing copy for promoting a workshop. We can pop open this drop down to see the internal dialogue. And there we go. So the way these reasoning models work is they'll generate a chain of thought. That's what you're seeing here. And once the chain of thought completes, you'll see the final output printed. So as we can see, while this locally hosted R1AB model is supposedly on par or even beating leading AI models like GPT-4o and Claude 3.5 Sonnet, the fact that it's not multimodal and has this slower System 2 style UX tells me that in the immediate, it's not going to be replacing apps like ChatGPT and Claude. Let's now compare the costs of using remotely hosted versions of some of the larger models offered by DeepSeek AI with the costs of using OpenAI. We're going to be comparing DeepSeek R1, aka the largest of the R1 series models from DeepSeek AI, with OpenAI's O1 model, because O1 is the OpenAI model that's most similar to DeepSeek R1. And for shits and giggles, even though it's not a part of the R1 series, we're also going to be comparing DeepSeek V3 with OpenAI's GPT-4o, because GPT-4o is the OpenAI model that's most similar to DeepSeek V3. The only prerequisite concept you need to understand to follow along is to know what a token is. In this context, a token is one building block of a particular AI's vocabulary. Most of the time, a token is going to be a word or a part of a word, but to be clear, a token represents any common building block of an AI's vocabulary. If you're interested in learning more about this token stuff, I recommend researching AI tokenizers or byte pair encoding as a starting point. In the following cost comparisons, you're going to hear the term input tokens, which generally speaking means the data that you send to an AI, aka the input tokens represent your prompts. And you're also going to hear the term output tokens. Generally speaking, output tokens means the data that you receive back from an AI in response to your prompts. Disclaimer number 1. At the time of recording, I don't seem to be able to purchase credits from the DeepSeek AI API platform, but I was able to find several American-based DeepSeek endpoints, and I did test them, so DeepSeek does work. But for the purposes of these cost comparisons, let's just assume that the DeepSeek AI API works and that the marketed prices are accurate. Disclaimer number 2. All prices shown are a snapshot of what things are like at the time of recording and are subject to change. Let's go! While OpenAI's O1 API charges $15 per 1 million input tokens, DeepSeek AI's R1 API charges only 55 cents per 1 million input tokens. And while OpenAI's O1 API charges $60 per 1 million output tokens, DeepSeek AI's R1 API charges $2.19 per 1 million output tokens. So, assuming comparable levels of intelligence as hinted in the research paper, this would imply that using DeepSeek AI's R1 API is approximately 27 times cheaper than using OpenAI's O1 API. As many people are worried about American national data security when it comes to the topic of DeepSeek, and rightfully so, let's also compare the cost of using DeepSeek R1 hosted by Fireworks AI, an American-based company. While OpenAI's O1 API charges $15 per 1 million input tokens, Fireworks AI's R1 API charges $3 per 1 million input tokens. And while OpenAI's O1 API charges $60 per 1 million output tokens, Fireworks AI's R1 API charges $8 per 1 million output tokens. So, assuming comparable levels of intelligence as hinted in the research paper, this would imply that using Fireworks AI's R1 API is 5 to 7 times cheaper than using OpenAI's O1 API. Remember, up till this point, all of DeepSeek AI's models have been open sourced, so companies all around the world can run them on their own infrastructure. As mentioned for completeness, let's also compare the System 1 style GPT-4o to the System 1 style DeepSeek V3, just to get a broader overview of the cost implications presented by DeepSeek's arrival on the international AI stage. While OpenAI's GPT-4o API charges $2.50 per 1 million input tokens, DeepSeek AI's DeepSeek v3 API charges only 14 cents per 1 million input tokens. And while OpenAI's GPT-4o API charges $10 per 1 million output tokens, DeepSeek AI's DeepSeek v3 API charges only 28 cents per 1 million output tokens. So, assuming comparable levels of intelligence, using DeepSeek's DeepSeek v3 API is 17 to 35 times cheaper than using OpenAI's GPT-4o API. And finally, let's compare the cost of self-hosting R1 against using the OpenAI O1 API. This is definitely not going to be applicable to everyone, but it's good to know. Remember, because DeepSeek models are open source, you can host them yourself. Here's an analysis by Alex Comerford, an ML engineer at Near AI, that compares the cost of self-hosting R1 on GCP versus using OpenAI's O1 API. There are a lot of variables at play here, but assuming you rent a beefy machine with 8 GPUs from GCP at the rate of $20 per hour for a single hour and are sending and receiving a non-stop stream of prompts and responses, then the cost of using a self-hosted R1 model is about 2 times more expensive than using the OpenAI O1 API. So, at the moment, compared to using the OpenAI O1 API, from a cost savings perspective, self-hosting R1 really only makes sense if you have a use case where you're constantly calling the model with almost no pauses, and if you can acquire some machines from some cloud provider, like for example, GCP or AWS, at a rate of under $10 per hour per machine. The other scenario I can think of regarding self-hosting R1 is if you own your GPUs. If you own your GPUs or your machine, your hardware, etc., that you're using to run these models, if you own those machines and the costs of running them are under $10 per hour per machine, then yes, you eventually will recoup the investments that you made into acquiring those machines. Hopefully that makes sense. If I said anything inaccurate, leave a comment. So in conclusion, the latest batch of models from DeepSeek AI are definitely something to pay attention to over the course of 2025. But my general assessment is that collectively we have to test them a lot more to see how good they really are. If you have data concerns in respect to American national security, rightfully so, I recommend using a self-hosted or American-hosted version of whatever DeepSeek AI model you're most interested in. Here are some US-based AI hosting providers you can check out to start with. If you're using DeepSeek in production, leave a comment letting us know your experience. And Sha Chu Jian. I think that means see you next time in Mandarin. Peace.